Hey guys, today we are going to talk about factoring once again. So before we get into this new method for factoring, I want to do a quick review of what we've already learned about factoring. We've learned that we always first check for a GCF, and if we find one, we pull it out to the front. Remember, sometimes there will be a GCF, sometimes there won't. Sometimes if there's a GCF, it's my only step. Other times I have to do more than one step. But either way, every time I take out a GCF, I then ask myself, now what do I have? Do I have a binomial? And if I do, is it perfect square minus perfect square? Because if it is, I can use the formula a squared minus b squared equals a plus b times a minus b. So if it is not in that form, so whether there was a GCF or not, I'm next going to ask myself, all right, well, what about a trinomial? Do I have something that's a trinomial with an x squared coefficient of 1 in the form x squared plus bx plus c? Because if I do, then I can use my factor sum tables to unfoil or undistribute, depending on which multiplication method you use. So we have always check for GCF. We have a method for if we have a binomial, even if it does have to be a particular type of binomial. We have a method for a trinomial, again, as long as it's in this particular format where we do have x squared and a coefficient of 1. Well, what about if we have a polynomial with 4 terms? Well, these here are the steps that we're going to take in that situation. We're going to group the first two and the last two terms together using parentheses. We will always put a plus sign between the set of parentheses. We will factor the GCF from each of the two sets of parentheses. Up until now, remember, 1 was never an important GCF for us. With factoring by grouping, if they have nothing in common, we will factor out a 1. Once we've factored out a GCF, we're going to ask if the two new terms have a common expression. If yes, we need to factor it out. So we're factoring twice here, factoring once here, for a total of 3 separate GCFs we're going to be looking for. If they do not have a GCF, check, are they exact opposite expressions? Or are you sure that you found not just a common factor, but the greatest common factor? Let's look at a couple examples where we're using this method. So here I am with example 1. In example 1, I notice that I do have 1, 2, 3, 4 terms. I notice that I do not have a GCF for all 4 terms. So I'm going to go ahead and go through these steps. I'm going to group my first two and have 2x cubed plus 6x squared. Put a plus sign in between and group my second two. That was step 1. Step 2, I'm now going to factor a GCF from each set of parentheses. So I see from my first set, both of those terms can be divided by 2x squared. Doing that, 2x cubed divided by 2x squared, my 2's cancel, x cubed divided by x squared, 2 of the x's cancel, leaving me with just an x. 6x squared divided by 2x squared, well, 6 divided by 2 is 3. X squared divided by x squared, I do notice that both of the x's cancel. Closing that parenthesis, and now I'm going to do the same thing with my second set. So the first thing I'm going to do is I'm going to drop down my plus sign and ask myself, what can 3x and 9 both be divided by? Well, they can both be divided by 3, so I'm going to pull that to the front and ask myself, now what's left in my parentheses? Well, 3x divided by 3 leaves me with an x. 9 divided by 3 leaves me with 3. So now I'm going to go up here to step 3. Do my two new terms have a common expression? Well, if I look at what I mean by my two new terms, I notice I have one term here, separated by a plus sign, and then a second term here. So they do have something in common. They have that expression of x plus 3 in common. So I'm going to pull that whole expression out to the front. When I do, I need to ask myself, what is left from the first term when I take the x plus 3 out? Well, I'm left with a 2x squared. I'm going to ask myself the same question about my second term. When I pull the x plus 3 out, what's left? Well, a plus 3. Remember, my goal of factoring is to create a multiplication problem. Because I do have multiplication between these two factors here, I have successfully factored my given polynomial. If I look at the second example, notice the second example is very similar to the first in the aspect that, once again, I do not have a GCF for all 4 terms because, again, that's always the first step I check with. I do have 1, 2, 3, 4 terms. So I'm going to once again go through that same process where I first group my first 2 terms inside parentheses, 5x cubed minus x squared plus, and I'm going to group my second 2, remembering that that negative does belong to the 15x. Once I've grouped them, I'm going to ask myself, does my first term that I've grouped in the parentheses, or does my first expression inside the parentheses have a GCF? Well, yeah, 5x cubed and x squared can both be divided by x squared. When I take the x squared out, notice I'm left with 5x. Since 5x cubed divided by x squared is 5x, remember you can always do some scratch work to see. Minus, well, anything divided by itself is just 1, so x squared divided by x squared is 1. I'm going to go ahead then and do the same thing for the second one. Asking myself, what can negative 15x and 3 both be divided by? I know they can both be divided by 3. So since they can both be divided by 3, I'm going to go ahead and take that out and pull it to the front. When I do, negative 15x divided by 3 is negative 5x. Positive 3 divided by positive 3 is a positive 1. And I can now look at my 2 new terms. Well, my 2 new terms, notice they don't actually have a common expression. They have a very similar expression, but I have 5x minus 1 here and negative 5x plus 1 here. Well, I know that 5x and negative 5x are related because they're opposites, and that negative 1 and positive 1 are related because they're opposites. I also know that if I divided a negative 5x and a positive 1 by negative 1, I would get a positive 5x and a negative 1, which notice is what I want in order to be able to factor another time. So I'm going to go ahead and do that. So this instead of is still going to be x squared. I will still have 5x minus 1. I'm not changing anything there. I'll still have plus 3, but now I'm also going to pull out or factor out a negative 1. When I do, notice that negative 5x divided by negative 1 is positive 5x, and positive 1 divided by negative 1 is minus 1. Well, since these 2 items here that both got factored out are right next to each other, couldn't I just multiply them? And notice that I intentionally put negative 1 in parentheses, so it did not look like subtract 1. So what do I now have? I now have x squared times 5x minus 1 plus a negative 3, which is the same thing as just subtract 3, times 5x minus 1. Well, both of my 2 terms have now a common factor of 5x minus 1. Well, that's good because there's 1, there's 2, sorry, I'm kind of out of room. So I'm gonna write my final answer over here on the side. So now, because they both have a 5x minus 1 in common, I'm going to take the 5x minus 1 out. Notice that when I take a 5x minus 1 out of this term, I'm left with just an x squared. And when I take a 5x minus 1 out of this term, I'm left with just a minus 3. So again, my goal is to get a multiplication problem. And notice that I do have multiplication happening between these 2 terms here. So I have correctly factored my expression. I would like to look at one more example. If you'd like to try and pause it and do it on your own, please do so. Remember that our first step, no matter what process we are using, is always to check for a GCF first. Okay, so let's go through this one. So first thing I do is I look at all my terms, and I notice that 8, 16, 24, and 48 can all be divided by 8. So I'm going to go ahead and pull that GCF of 8 out to the front to begin with. Doing this, I now have taken a GCF out, but I still do now have 4 terms inside of my parentheses. So I'm going to see if I can't factor that further by factoring by grouping. So I'm going to go ahead and leave the 8 out front, and I'm going to use some brackets so that my parentheses don't get confusing. I'm going to go ahead and group my first 2 terms, x cubed plus 2x squared, put a plus sign in between, and group my last 2 terms. And then again, I'm going to use that bracket on the end, so once again my parentheses don't get confusing. This 8 is always just going to keep hanging out front. And then I'm going to go ahead and find a GCF for each of my 2 terms, or each of my 2 groupings inside. So I notice that x cubed and 2x squared can both be divided by x squared. When I do that, I'm left with x cubed divided by x squared is x. 2x squared divided by x squared, I'm left with just a 2. My plus sign drops down. If I ask myself, what can 3x and 6 both be divided by? I know they can both be divided by a positive 3. Asking myself, okay, once I divide that positive 3 or factor that positive 3 out front, what's left? Well, 3x divided by 3 leaves me with an x. 6 divided by 3 leaves me with a plus 2. I'm also going to go ahead and close those brackets that I started in the beginning. And then again, my 8 drops down. Again, I'm going to keep brackets so it's less confusing. And then I'm going to ask myself, what do each of my 2 new terms, again separated by that plus sign, have in common? Well, notice both of them have an x plus 2. So I'm going to go ahead and factor that x plus 2 out. Well, when I take an x plus 2 out of my first set here, what am I left with? Well, aren't I just left with this x squared? And when I take an x plus 2 out of my second set, what am I left with? Well, aren't I just left with that 3? Closing my bracket. I see that I now have 8 times x plus 2 times x squared plus 3. Because this is all multiplication, those brackets aren't necessary. I really just had these brackets here in to help keep me organized so that I didn't accidentally put my 8 and my x squared together. So I'm going to go ahead and rewrite this one last time without my brackets. And my final answer is 8 times x plus 2 times x squared plus 3. My ultimate goal again with factoring is to make a multiplication problem, and notice since these are all being multiplied, I have reached that goal.